High pressure is here and it's stuck on top of the UK throughout this week. But if you're expecting the same kind of sunshine records that we saw during the spring, under similar circumstances, well, you'll be disappointed unless you're on top of a mountain in Scotland. Most of us have also got gloomy skies because a layer of low cloud is also stuck over the top of the UK throughout this week. Why is the high stuck? Why is the low cloud stuck? And when will either shift? I'll be taking a look at those aspects of this week's weather forecast in the Met Office Deep Dive. We do these every Tuesday. If you enjoy them, tell your friends about them, spread the word, send us a comment, a like, and of course, if you haven't already, please do subscribe to our YouTube channel. It'll only encourage us to do more of this sort of thing. Now, before I get started talking about the anticyclonic gloom and the causes of it, well, it's worth remembering that it has actually been a remarkably sunny year so far. So what we're seeing this week is a bit of a blip compared with the last few months. And just to prove the point, I've got a sunshine graph here that shows how each month's sunshine has played out for the last 10 years. So each of these bars represents a month where we've got a yellow colour above the black line in the middle. It shows an above average sunny month, and where we've got a grey line underneath the black bar, it shows a duller than average month. And I thought this was interesting because it shows how many months so far this year have been much sunnier than average. January, not February. February is the only one so far, not including October of course, so far that has been duller than average. Because since March, we've had 7 consecutive sunnier than average months. A particularly sunny spring. In fact, it was, if you remember, the sunniest spring on record. And then each of the summer months was sunnier than average. And September, even though we saw a lot of rain in September, it was still sunnier than average. These are UK values, of course. It has varied a little bit region to region, but most regions have seen a lot of sunny months so far this year. And the fact that we've had 7 consecutive sunnier than average months, well, I look back at the last 100 years or so, it's not happened in the past 100 years or so, just a bit more than 100 years, back to, I think, 1910. And that just shows how remarkable this 7 consecutive month spell has been. I imagine October might break that consecutive running streak because of the dull weather that we've got this week. And in fact, it's similar to last autumn. So if you look at that, all these duller than average months last autumn, and particularly December, this grey spike way down last December, a very dull month. And this is the last time we were talking about anticyclonic gloom. Why was December so gloomy? Why was the spring so sunny? Well, it's the same reason for both. Because if I show you the pressure setup for December, this is the pressure anomaly for last December, and it shows this great big high pressure dominant over the UK. But also, in April 2025, a great big high pressure dominant over the UK. So we had these spells of high pressure throughout last autumn and into December and throughout the spring, but with very different results. In the autumn and in the winter, we saw a lot of low cloud, very gloomy weather. In the spring, we saw a lot of sunshine. Why is there that difference? Well, it all comes down to the strength of the sun, effectively. And this is illustrated by looking at a tephigram, in other words, an upper air observation. So this is where we send a weather balloon up into the atmosphere and we measure a number of things. We measure the wind speed, that's what's shown on the right here. We also measure the air temperature and the dew point temperature. Now, the dew point temperature takes into account the temperature and the moisture in the atmosphere, so it's effectively measuring the temperature at which the air has to be cooled for the atmosphere to become saturated. And this graph here shows what that weather balloon taken from Northumberland, Albemarle, on Sunday morning, and there's a reason I chose Sunday morning, what that recorded. So it went up in the atmosphere. Now, normally you expect temperature to decrease when you go higher in the atmosphere, but there is a point down here at about 700 or 800 meters where the temperature actually increased, just by here. And at the same time, the dew point went way down, a really dramatic drop in dew point temperature Now this is called an inversion. And what we've got in the lower 700 or 800 metres is a lot of mild, moist air, and that's where the low cloud is. So where you've got the dew point temperature and the air temperature coming together, that's where you've got cloud, basically. And they're coming right together there, about 700 metres or so, towards the surface. But then immediately above that, you've got this inversion where the temperature actually rises with height, but the dew point goes down, so it becomes very, very dry. And this is typical of high pressure, because in high pressure you get sinking air. That sinking air warms up and dries up. So as a result, you get all this clear air right the way down towards the surface. But at the surface, you've got this small layer of warmer and moister air because of basically, that's where we've got the land, we've got the sea, so we've got all these dynamics that are happening near the surface, this rising bubble of air up to a certain point, up to the inversion. Above the inversion, all the air is sinking, drying and warming up. And most of the UK has been covered by this thin layer of moist and mild air through this week, hence the low cloud. But there are some places that are poking above that low cloud. And if we had the same atmosphere in the spring and summer, when the sun is so much stronger, what the sun can do then is it can give the air towards the surface enough buoyancy to break through that inversion. So it lifts the low cloud into the drier air above, it mixes it all up. And so sometimes you start off with low cloud in the summer during the morning, but then the sun lifts it into the drier air above, it all gets stirred up and you get a nice sunny late morning, afternoon period, similar in the spring. But at this time of year, the sun isn't strong enough to give it that buoyancy, to lift it into that drier zone above. And so it all stays trapped. That low cloud remains trapped because the sun is too weak to lift it into the dry air above. However, in this kind of situation, there's another mechanism for getting some sunshine out of this situation, and that mechanism is to rise above it, and that's what the hills and mountains of the UK can do. And that is in fact what we saw, given the fact that the lid on that low cloud, the top of it is 700 or 800 metres. There are, of course, parts of the Pennines, the Scottish mountains that are above that. And we saw this remarkable footage, Richard Peacock credited for this, Slightside Lake District, not far from where that balloon observation was taken. So about the same time, this is Sunday, and you can see there's the low cloud, but he's above it. He's above that inversion, clear skies, and very dry air as well. It's worth mentioning that about the same time, Sunday morning, as that weather observation was taken, the weather balloon, we saw a remarkable observation that was taken on Great Dun Fell, Pennines, and that's 847 metres high. And that observation gave a temperature of, on Sunday, the maximum temperature there was 20.4 Celsius. That was the warmest place in the UK on Sunday, but also a dew point of about -18, -19 Celsius. And so they had a relative humidity of 4%. That's drier than a lot of the world's deserts. So you get above that low cloud where the relative humidity, of course, is 100% because the air is saturated. That's what it means when you're in a cloud. And suddenly the relative humidity drops down to 4% on top of the Pennines, and it's the warmest spot in the UK. That was also Great Dun Fell's warmest October day on record. So quite remarkable things can happen in these situations where you get high pressure, you get the drying and the sinking of the air, and you get the sunshine above an inversion. Not only that, but you can also see where the cloud breaks up over the mountains and stays clear downwind of the mountains. Here's a satellite image from Monday afternoon. Here's Wales, by the way. There's London, there's East Anglia, there's Northern England, Northern Ireland and Scotland. Most of the UK blanketed by this thin layer of low cloud. But parts of Northern England, particularly where we've got the Pennines, North Wales, Scotland, seeing the best breaks. And they've all got one thing in common, they've got mountains. So where the air is moving over the mountains, not only the hills poking above the low cloud, but the movement of the low cloud over the mountains helps to just mix it into that drier air and create large gaps, even where you haven't got mountains. So you've got the air downwind of higher ground. And one last thing I want to show you This observation taken on Cairngorm, and this is the trend in air temperature and dew point taken from, I think, midday Sunday through to 8 a.m. Monday. And so this shows how the air temperature, which is the yellow line, didn't vary much. On top of Cairngorm, so this is 1,200 metres or so high, and the air temperature wriggled about a little bit, but typically it's around 8 degrees, rising up to 12 degrees there, typically staying around 8 to 12 degrees during that 36-hour period or so. But the white line is the dew point, so this is a measure of how much water vapour is in the air. And at first it was bang on the same as the air temperature, so where they're together, obviously Cairngorm is in the cloud at that point. But during Sunday evening, from about 5 p.m, you see this steep drop in dew point temperature from about 8 degrees down to minus 28 degrees, 30-degree drop in 3 hours. And that's simply the inversion dropping in height. So it can go a bit higher, it can go a bit lower, depending on how the high is shifting around, how the winds are changing. But a dramatic drop there. And all of a sudden, there's this stark difference between the dew point and the air temperature. So on top of Cairngorm, you'd go from being in cloud to being above the cloud and having beautiful clear skies above. And it's such a difference in such a short distance from being in that low cloud to being out of it. And it's such a thin layer of low cloud. This is one of the things that I think about when I think there are certain aspects of meteorology where a very small difference in the weather has a big impact on how we feel the weather. Another one might be the transition between, say, 1 degree and raining and -1 degree and snowing. Big impact there from raining to 10 centimetres of snow on the ground. You're only seeing a temperature shift of a degree or two. You wouldn't necessarily notice a temperature shift of a degree or two if it was 17 degrees and raining, but you do, obviously, when it's reaching that threshold. It's similar with low cloud. It's such a thin layer of low cloud. It's such a small difference when you look at the bigger picture, whether you've got a bit of cloud in that layer or no cloud. But on the ground, it's a huge difference whether you've got grey, gloomy skies or whether you've got sunny conditions. And that's why in this kind of situation this week, the computer models struggle with modelling the low cloud. It's shifting about, it's very fickle, it's a very thin layer. It'll get broken up by some hills and mountains and not by others. It will pass over slightly drier parts of the land and slightly moister parts of the land. And where that thin layer of low cloud remains or where it gets broken up is very difficult to model, where you've got high pressure slap bang over the UK and very little wind. So the models have a hard time predicting it and modelling it. And so your weather apps will not necessarily give the best guidance about whether it's going to be sunny or cloudy. And you think, such a big difference in our perception of the weather, whether it's grey skies or blue skies and strong sunshine. But ultimately, it's only a very subtle difference in the computer modelling of the atmosphere. So that's why your weather apps might be a little bit wrong at times this week, essentially. And I'm sure we'll get a lot of comments about that. Now, moving on to the forecast and addressing the question about why high pressure is stuck over the UK, why it's been with us for the past week or so, and why it's going to continue to be with us for some days to come. I want to take a look at the much bigger picture and count the number of ridges and troughs in the atmosphere. So this is a global picture. You can see Africa there. There's the UK, just by there. Scandinavia, North America. And this is a really nice way of being able to count how many wriggles in the jet stream there are, because there are quite a few at the moment. Let's count them. It's the couplets of red and orange. I've gone through this before in a previous deep dive, but what we've got here is we've got a blue area over eastern parts of North America, a red area or orange area over, that was western parts of North America, red area over eastern parts of North America, and then a blue area over the Atlantic, red area over the UK. Where we've got the blues, of course, we've got lower pressure, we've got the jet stream dipping to form a trough where we've got the orange areas, we've got a ridge, we've got high pressure. So we've got the high pressure over the UK, the jet stream well to the north at the moment. Then we've got this trough, this low pressure over eastern parts of Europe, and then another high pressure over central parts of Asia, and so on. But if we count the blues, 1, 2, 3, 4, I think there were 5 actually when I counted before. Let's count the reds. 1, 2, 3, 4, 5. There's effectively 5 of these wriggles. So what we call it is a wave number 5 pattern. And again, I talked about this in previous deep dives, but if you haven't watched them, then this basically is a measure of how wriggly the jet stream is. A more typical pattern would be a wave number 3 pattern, where you've got 3 big ridges and troughs and a flatter jet stream that wriggles less, but with these broader waves. And so this is a situation where you've got more wriggles and they're a bit more amplified. And this particular number, wave number 5, but there's also another one called wave number 7, they are particularly interesting because they can persist for longer than, say, wave number 3 or wave number 4. What I mean by that is that when you get a wave number 5 pattern, the ridges and troughs, the highs and lows, tend to get stuck in the same place. So simply by counting the wriggles in the jet stream, we can figure out whether these highs and lows are going to stay in the same place. And the reason they stay in the same place is because it matches, this wriggly pattern, this frequency matches the naturally occurring frequency from the topography of the northern hemisphere. What do I mean by that? What I mean is that there are stationary highs and lows that we find in the northern hemisphere as a result of the jet stream meandering over hills and continents and oceans and so on. So when the jet stream, for example, the Rockies is a good example. When the jet stream meets the Rockies, it slows down. It kind of piles up over the top of the Rockies, so you get higher pressure there. It's forced to pile up over the Rockies. And then on the other side of the Rockies, you get lower pressure as it all whooshes back through again. And so you get a natural frequency that is about the size of a continent where you've got a ridge on one side and a trough on the other. Now, sometimes the jet stream can be, as a result of thunderstorms in the Pacific or deep lows that are ex-hurricanes or so on that come into the Atlantic, or ex-typhoons in the Pacific, sometimes the jet stream can be a very different frequency to that naturally occurring frequency, and then you've got the two frequencies working against each other. But if the jet stream sets itself up so that it is roughly the same frequency as the lows and highs, let's see if this will work with a pen. Oh, that's the wrong one. Here we go. I haven't tried this out to practice, so it might... Oh, that's way too small. Let's try that one. Okay. This is live experimenting with my pen to see if I can explain it better. Let's see. So, sometimes the jet stream will, for example, come over like this, and these broad meanders. But that frequency is different to the naturally occurring one as a result of the Rockies. Other times, it will match the frequency that we've got coming in. It will be of a lower wavelength, and you'll get the ups and downs in the frequency working together, basically. And when that happens, those troughs amplify, the ridges amplify, so the frequencies are working together. So this is what's known as planetary scale resonance, basically. And when that happens, the whole thing becomes amplified and it stops moving along. And that's what we've seen this week, essentially. The whole thing becomes amplified. It starts off, say, over eastern parts of the Pacific into North America, and then that same frequency works its way across the globe, amplifying all the while and becoming stuck, leading to high pressure in the same place through the week, low pressure in the same place through the week, until something happens. And in fact, something is going to happen this week. We've been trying to locate the source of this disturbance to the jet stream this week that results in a big pattern shift later in the weekend. But actually, it's one of those situations where it's really quite messy and it is difficult to locate the disturbance. But it's something to do with deep low in the Pacific or some thunderstorms in the Pacific that cause this jet stream pattern over North America to shift, and that disturbance then ends up spoiling the whole pattern, so it becomes very different for next week. So planetary scale resonance, wave number 5 pattern. I know I've not described that as best as I was expecting to. Maybe I'll come back to it in a future deep dive. It is actually a bit more relevant in the summer because there's some research that suggests it's a weather pattern that's becoming more common in the summer months and can lead to persistent heat waves in places. So yeah, I think one to return to in the summer when we talk about heat waves. But for now, let's take a look at how the weather's changing through this week. Now we've got the high all week, we've got this slowly shifting low cloud covering the UK, breaking up in places, as I say, difficult to model. Friday, high pressure still in roughly the same place. Saturday, it's moving, it's starting to migrate, albeit slowly, to the east. Weather fronts starting to appear. So Saturday starts off, for most of us, a lot of fine weather, and in fact with that change in wind direction, a bit more sunshine for many of us, so we're starting to lift the anticyclonic gloom. However, it's not till Sunday that the low in the Atlantic begins to break through and begins to arrive from the west. Now this is where the Met Office model has that low, just to the northwest of the UK by midday Sunday, swinging some weather fronts in, outbreaks of rain turning up, most likely in this situation drier towards the east. But we don't just look at the Met Office model, of course, we look at lots of different models, and now we've got the ECMWF data in our system. We can look at all these different model simulations that ECMWF run of their model. The 0 simulation there, that's the control model. So it's the same starting positions as their operational model or their higher resolution model. And then we've got all these different runs where the starting conditions are slightly tweaked to see how much that makes a difference. And if I fast forward to Sunday, about the same time, let's go back a bit, about the same time as that Met Office model run, the control model's got the low pressure to the southwest, so rain coming more into the southwest of England, Wales, Northern Ireland and so on. Remember, the Met Office model had it there. But for this same time, where I could pick all sorts of different model runs, and they have the low pressure in all sorts of different positions. They've all got it moving in, but there's a big spread by this stage in terms of whether it's to the southwest of the UK or to the northwest of the UK. Now, the Met Office ensemble, all the different members of the Met Office ensemble run, had the low pressure more shifted towards the northwest of the UK. The European model have more towards the southwest. And in fact, we can show all the various tracks of that low on here as well. So the blue lines are each track from each model run. And if I play this forwards, this is Sunday. Not that many tracks actually, initially. That's partly because of differences in timings of that low as it moves in, but also partly because it's not that deep. So they're quite faint blue lines. We're not looking at the brighter colours here, which would indicate a particularly deep and stormy low. We're looking at a fairly shallow area of low pressure. This is Sunday night, and then if I play it forward, you'll see by dawn on Monday, we've got more of these lines appearing. So yeah, the track of that initial low could be anywhere from northwest of Scotland to southwest of England or even northeast of England. And there's not only differences, slight differences in the depth, but also differences in its timing. So 24-hour differences, whether it's Sunday or Monday that moves across the UK in some of these model simulations, and also differences in its latitude. So a lot to play for with this low, and it's not surprising, really. We've got high pressure that's quite dominant over the UK, and when we get these blocking highs in place, they can be difficult to shift, and the computer models can be, they can find it challenging to model when exactly the high will give way and allow these lows to turn up. You'll notice another low hot on the heels of that one, in between, a little bit of a ridge. But if I play this forward, this low coming in. Also, some uncertainty about the track of it. This is the initial low, or the tracks that eventually make their way across the UK during Monday and Tuesday next week. Either way, there's going to be outbreaks of rain slowly crossing the UK Monday and Tuesday. Then a respite, perhaps Wednesday, Thursday, before this next low turns up. But again, a big spread in the tracks of this. Not only that, but we're seeing some deeper lows in some of the model runs as well. So this low perhaps a bit more of a larger and deeper feature than the initial low. Here's the initial low clearing by this stage into Denmark, into Norway and Sweden. The next low coming along, more likely by the looks of it to push to the northwest of the UK rather than the southwest, but again a lot to play for. There's a number of different tracks here, and if I play that forward you can see how those tracks evolve through time. So yeah, a lot to play for, like I say, but there are some themes that we can pick out for next week, and the best way to visualize these themes is to take a look at the summary of not only the European models simulations, but the Met Office simulations, the American simulations from the GFS model. And this shows the summary of all of those by weather pattern for the next 2 weeks. So this shows the next 2 weeks. We've got Monday the 27th of October at the end here. And the most likely weather patterns, the probability of these various weather patterns for each day. Typically, high-pressure dominated weather patterns are in the reds and oranges, and the blue colours represent low-pressure dominated weather patterns. So you can see a big change around Sunday, Monday, Tuesday, where we go from the reds to the blues. What do they look like? Well, there's a selection of different types of blues. It's blues all the way through next week, so yeah, low-pressure dominated, but the different colours indicate a lot of uncertainty about what type of low and where it goes. Just to click on the most likely there for Tuesday the 21st of October, here's the UK, and I'll take off the rain there because it's difficult to see the UK, there's so much rain. There's the low, just to the west of Ireland, south to southwesterly airflow, and put the rain back on. The brightest colours there across parts of Wales, the south and southwest. So that's the most likely, but if I click on the second most likely, you can see the low pressure in a bit of a different position. It's more in the North Sea. Again, some bright colours there across the country, indicating a lot of wet weather through the day on Tuesday. And it's similar on Wednesday. This is the most likely, but this is another plausible scenario. Again, a lot of wet weather with this low pressure in a slightly different position. Here's another area of low pressure clearing to the North Sea, and here's another scenario, for example. Again, bright colours there for Western Scotland, Western England and Wales. So, in other words, let's put the temperature anomalies on as well. Slightly cooler than average because of the wind and the rain and so on, but not much. In fact, we click on other model runs, bang on average there for that scenario. So, yeah, next week, the general theme is low pressure dominated, spells of rain, but these low pressures are going to move slowly across the UK. So these are slow moving spells of rain, most likely affecting western and southern parts of the UK, but all areas likely to see some wet weather. And that's really summed up by this, which is from the European model again. And it shows the 7 days from Monday the 20th to Monday the 27th of October, the rainfall anomaly for next week. And this is next week, actually. The previous one, I'll go back to it just to show the contrast. This is this week, much drier than average across the north and west of the UK in particular. And then this is next week, Monday to Monday, much wetter than average across the south and the east in particular. Of course, all areas likely to see spells of rain, but compared with average, the south and southeast is a drier part of the UK in October, so spells of rain through next week are likely to be more above average than, say, for the likes of Western Scotland, even if the magnitude of rain in Western Scotland is higher than towards the south east. That sums it up for next week, but just to look a bit further ahead and go back to our graphics here. In fact, is it this one? Here we go. The top 3 most likely weather scenarios or weather patterns. There are some signals. So this is next Wednesday, but going into Monday the 27th of October, for example. And there are some themes that we can pick out. One of them is that low pressure is more likely to the east with higher pressure to the west. That's what these top 3 scenarios are showing, and some other model output that I looked at earlier. That low pressure to the east with higher pressure to the west would give more of a northwesterly airflow, still quite showery, not necessarily completely calm and settled, but with a northwesterly airflow for Monday the 27th of October, so the last few days of the month. That would mean lower temperatures, a little bit lower, but not much lower. We're not talking about a cold spell by any stretch of the imagination. So next week, fairly average temperatures, spells of rain slowly moving across the UK as low pressure finally returns. The one uncertainty there is when exactly it becomes widespread across the UK and the track it takes. But next week's looking fairly wet with low pressure in charge. Then by the weekend, at the end of next week, we start to see this transition where low pressure is more shifted to the east, higher pressure to the west, perhaps more of a northwesterly, and cooling down of things, but also staying fairly showery with that northwesterly airflow. One last thing I forgot to mention, a little fact to leave you with, and it's on the topic of low cloud, because I was talking to our expert meteorologist upstairs about the inversion. Loads of interesting stuff around inversions, actually, and here's one that I wanted to pass on, courtesy of Neil Armstrong and Dan Holly, who I was chatting to about inversions. If you were to stand, say, in that low cloud layer, just below the inversion on top of a hill, and you were to shout at a mate or yodel, that's what they suggested, at a mate on a different hill, also just below the inversion, then that's quite an effective telecommunications technique, because the sound wave would not necessarily go above the inversion, it would bounce along the bottom of the inversion and allow sound to travel much further than it would in a different kind of atmosphere. So yeah, that's quite a neat little trick if you want to try that out with some friends at the weekend, perhaps, if we still got the inversion. Stand on a hill just below the inversion. So you're in the cloud, you can't see your friend, but you can hear them as if they're much closer to you than in reality. But I'd leave you with that one. But thank you for watching this. I hope stuff made sense. Let me know if various aspects didn't make sense, and I'll try and come back to them in a future deep dive, particularly that wave number stuff. I don't think I explained that very well. But live and learn, and yeah, have a good week. Bye.